Hello everyone. Welcome back to Dr. Liu's VCE Physics channel. Today, let's learn together about the 2019 physics examination. We will focus on questions related to light as a wave. My explanations may need to be revised. If any teachers, parents, or students find errors, please feel free to provide your guidance. Medium 1 to medium 2, towards the normal. So, N1 is less than N2. Medium 2 to medium 3, away from the normal. So N3 is less than N2. However, refraction angle 3 is larger than incident angle 1, so N3 is less than N1. Finally, N3 is less than N1, and N1 is less than N2. The light speed is inversely proportional to n, so light speed is the fastest in medium 3 and slowest in medium 2. So, D is correct. Ask for the minimum value of the liquid's refractive index so that some light will just cross the interface into the liquid. Just crossing the interface into the liquid means the refraction angle is 90 degrees. Substituting 90 degrees into Snell's equation, we calculate the minimum value of the liquid's refractive index. The key information is that the time taken for point P on the string to move from maximum displacement to 0 is 0.120 s. Point P crosses 0 4 times during one period. So, the period is 4 times 0.120 s. Substituting the value of wavelength and period into the equation, we calculate the speed of the wave. The speed of the wave is divided by frequency. This quotient is the wavelength of this wave. If this wave is a standing wave, the string length must be a multiple of half wavelength. The string is 6 m, and the wavelength is 5.3 m. It is obvious that the string is not a multiple of half wavelength. So, this wave cannot form a standing wave. Students have set up a double-slit experiment using microwaves. The beam of microwaves passes through a metal barrier with 2 slits. They determine the positions of maximum intensity to be at the points labeled P0, P1, P2, and P3. Calculate the path difference between S1P3 and S2P3. This path difference is 3 times the wavelength because P3 is the third peak. So, we divide this path difference by 3 to get the wavelength. Substituting the value of wavelength and speed of light, we calculate the frequency of this microwave. The signal strength between P0 and P1 is the minimum because the path difference is half a wavelength. This results in destructive interference. Light is a transverse wave. Polarized light is such that its plane of oscillation is in one direction only. The effect being observed is dispersion. The refractive index of the glass is different for different wavelengths, so different wavelengths refract at different angles. This is why the different colors exit the prism at different angles. The effect being observed is dispersion. The refractive index of the glass is different for different wavelengths, so different wavelengths refract at different angles. In light as a wave, 2 multiple-choice questions are worth 2 marks, and 3 short-answer questions are worth 13 marks. The overall score for this section is 15 marks. With a total possible score of 130 points, the percentage for this section is 11.5% of the total score. If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.